This is actually level 1. It's not GamersNexus. I'm here. I've co-opted Steve's space, and I've got some very important, I'm not worthy folks from AMD. Amit and Anil, welcome.
Yeah, good to see you.
Good to see you, Wendell.
They know everything about everything Zen, all versions, all time and space. And I have an EPIC system with a BIOS and a CXL module and a whole bunch of memory. And I want to know what the BIOS options actually do. I want to know where the rubber meets the road, because it's like I can guess, but I don't know. So let's go through our Supermicro. This is an H13 with a 64-core F series, 5 gigahertz EPIC CPU, and yeah, there's all kinds of options here. Oh, and I'm also making them use the Model F keyboard.
Where did you find this old relic?
Oh no, it's not old. It's brand new. You get it from modelfkeyboards.com. So where do we want to start?
Yeah, let's go through one of the things is every person who uses a system, one of the things is like black magic arts on the internet. Everyone comes to us and like, hey, what BIOS tuning we can do? It's like a common question that we get asked, right? And realistically, technically, you shouldn't be doing anything. If we've all done our things right, for 95% of the time, things should just work out of the box for
But this
most
is
users.
level 1, and we do IOMMU, we do pass-through, we do like multi-GPU sharing. We do things like disabling spread spectrum, which the FCC frowns upon.
So
Technically frowned upon.
technically frowned upon. You cannot ship stuff like that,
Yeah,
right?
yeah.
But yeah, so we want to just go through, since a lot of your users are giving support to people who want to tune things. If you want that extra 5% in today's era where everyone wants the maximum out of the system, you can just go through a typical system like this and go through some of the options that AMD has to offer and look through what do these options do, what do they mean, when do you want to use an option for one workload and when do you want to not use an option for a workload, right? Those are critical trade-offs that you need to consider before you just randomly go change BIOS options. Because I can't begin to tell you so many times where someone's complained about something and we've asked, did you change something? They're like, no, we didn't. And then we go review the options and turns out they've flipped around 15 BIOS options because they went through a forum thread somewhere and it said, turn this magic BIOS option on for 20% more performance.
Probably our forum, I'm so sorry.
Yours is pretty good. We scrub your forum, we scrub Steve's forum, so you guys are good. But it's a good idea to educate people who want to learn about things. Information is always useful, so the idea is to go through all these options. So yeah, wherever you want to begin.
Sometimes it's not even performance. Sometimes it's just features or things like that. So if we, when we first land on main, so we've got the BIOS version, which is a combination of the version and the date, I learned, because you never know where you're going to get a special BIOS build. And then you have a menu like this. And sometimes you have AMD CBS and PBS in here. You see that more often on desktop boards than server boards. But some of those options are buried under CPU configuration and Northbridge configuration. I think we can skip boot. Let's just go right into CPU. So workload profile. This actually sets a ton of options.
Yes. So this is something that we introduced starting Milan a little bit and also really put a lot of effort into Genoa. The idea being we do not want our customers to go flip around 20,000 options. But there are common use cases that our processors serve in market to a big class of customers, right? So HPC is a great example. So if you go to the HPC option, it'll turn on all the options underneath that is typically used by HPC class users. For example, they want a very consistent performance from the system. They want the maximum bandwidth from the system. They do not want a lot more idle performance benefits. They want more like runtime performance. It's like the best analogy I can give you is when you buy an aircraft, you care about the speed, your fuel efficiency when it's, gliding, not necessarily when it's taxiing, right? So these options kind of change those metrics and bias it towards more performance consistency. Same for I/O, right? I/O is another case. We kind of kicked off this market that we really wanted to with Naples with 128 I/O lanes, where you suddenly started seeing systems with multiple NVMEs, multiple network cards, streaming I/O. And what you want to do the system for I/O is maybe different than what you want to do when you want to bias it for cores and memory, right?
Yeah, we have customers using it as like a big disk controller.
Yeah.
It's a EPIC server CPU, but it's
the only job of the CPU is to move the data from the disk to the network. I don't care.
And we are very
you
happy
can imagine
doing
that the
it.
configuration would be different for that sort of application.
And we are very happy doing it. It's just challenging to have one option that basically gives you the best for both. So our default considered like an average use case where you're doing a mixture. But if you use these profiles, you should be able to bias like 99% to what your workload will need.
I noticed on AMD, I think it's the performance blog, there is a couple of PDF white papers.
Those are the white papers, basically. Exactly what I was going to say. You've been keeping up with us, right? So if you see here, like telco is another big market where people are using Epic for obvious reasons, and virtualization being the single biggest use case we have, right? Yeah. And that's another profile. So fingers crossed, most users, all you should be doing is finding this option in your board and setting it to your use case if you have one. And if you don't know your use case, keep it disabled. Yeah. All right.
And the white papers will explain all of the other options, because like you could go set a conflicting option or whatever, because that option changes a ton of stuff.
Yeah. So you don't want to, exactly, the white papers are there to serve as a detail of what we're actually doing, but those should be able to get you 90% there.
SMT control is pretty obvious, and just to dispel the myth or the rumors or the internet, like SMT is great in enterprise scenarios. In like 9 out of 10 or even 99 out of 100 enterprise scenarios, you don't want to disable SMT.
Yeah, do you want to talk about it since you designed it?
Well, the way I've described it, it's our number one feature for per watt. Right? Yeah. So frequency is obviously the biggest bar, right? But after that, SMT is in some 30-40% free performance per watt.
Even just like not just 30-40% performance per watt, but even just like basic operating system tasks, like in the Linux kernel when you're juggling a million threads, not having to pop stuff off the stack, and it's like, no, we'll just keep this core running in this context, and so that's free performance there because you're not moving stuff around.
And it's great you say that, because when we got into Naples and we started, Naples was a great processor for HPC, and a lot of our customers were disabling SMT. We were like, hey, curious, why are you disabling SMT? Oh, we've been doing that on our older systems forever. And we're like, wait, have you tried it with Naples? And they're like, no. We go, hey, please try it. We think it's going to be great. And what ended up happening is in HPC, you typically want your job scheduler to use all the cores available for compute. So what ends up happening is the scheduler or the kernel itself or your helper libraries for I/O or something don't have any place to run. So if you disable SMT, they have the kernel has to swap out an actual user process. But when you have SMT and you have one of these threads available, you're going to have some perf variation, but it's better than blocking an entire thread and swapping it out for multiple milliseconds, right?
Yeah.
So
a lot of people don't realize that.
People
and
don't
it got so much better in Zen 5.
It's been getting better and better and better. We are hoping to keep making it better, right?
No, we're committed to SMT.
Yeah.
So core performance boost. This is just turbo, right? Turbo as we know it.
Yes, but I'll tell you a fun story. Some applications license based on frequency as well. So there are some customers who actually come to us and say, we do not want boost. Like they buy the CPU for the memory bandwidth, but they're like, hey, just whatever your base frequency is, just stick to that, don't go higher. So there's options there. Also, one thing to note about this option, these two options, the kernel has a couple of options like no SMT, but no SMT is not what this option will do. This will even eliminate the option for the kernel controlling SMT. So I highly recommend, if you think you're having something first level, to go tell the kernel that I either prefer the first cores or don't do multi-threading, or no SMT, so you can play around with it. Turning it off from the BIOS basically ensures that you have to change the BIOS option to turn it on again, right? Now, on one system, it's okay, you, me, and Amit have access to the system, but imagine like a cloud scale service, right? And then you disable it from BIOS, and then someone has to write a tool or do things. So it's probably better to leave both of these settings on. Even core performance boost, there's a kernel tunable. You can put the link in the description where you can go turn it on and off on the fly. And Windows can do the same as well.
Global C-state controls, pretty self-explanatory.
No, that one we should talk about.
Okay.
Highly, highly recommend you never disable this. Because what it'll do is it'll eliminate all the ACPI tables that tell the kernel that the processor can go into deeper C states. For whatever reason, if you want to disable lower C states, the highest recommendation is to go to your kernel and tell the OS not to prefer certain states. So just as a recap to users, there are 3 major C states in software that you can see. There's C0, which is active. There's C1, which is like we are almost about to run something. So it's like we are about to execute something, but we still want to save power. So the exit latency is very quick for C1. And C2 is mapped to hardware C6. Amit, you can talk about C6 a little bit. Do you want to tell people what happens in C6?
Yeah. So C6 is, like you said, the deeper C state. So, they're typically accessed by doing x86 halt instruction or an M wait, something like that. So yeah, like you said, the first step is C1. In C1, we basically turn off the clocks of the core, but we keep it powered up, and it can respond to things like probes or respond more quickly to interrupts.
Or network requests or interrupts or anything like that.
So it's there. Now we have timers, and then if we're in C1 for a certain amount of time, don't get any sort of access, then we go into C6.
Not like your watch timer. You just look at your watch.
Yeah, and people are confused because in the OS it's called C2, but we map it to what we call C6. And in C6 we actually power off the cores for more savings.
Power savings.
All the context gets saved, right? And then if you want to come out of C6, you have to restore all of that. So latency of coming out of C2 is pretty high, right? And our typical recommendation has been, in our experience, disabling C2 will actually negate performance. Because anytime the core is not doing anything, if we can turn it off, we can take that power and give it to the other cores, or we can do something better with it, or we can control it. Now, the only scenario where in those cores, like the kernel allows you to set this per core. What you can do if you want to really do optimization to the hilt, as some of your level 1 users want to, is typically the kernel knows when you're about to access storage. So even if that core that handles the storage is in C6 or C2 from the software's perspective, it can wake up that set core in time to do the storage operation. The problem happens, even network transmit is okay because the kernel knows I'm about to transmit a send file and turn on the network and do everything, right?
Yeah.
The problem that you run into is receive. Because imagine the core is sleeping. It's like you're in bed and someone knocks the ring bell, right? So that time you want to be ready for the person.
And that applies for NVMe as well, because you get an interrupt from the NVMe and it has to deal with that. And that's why polling is faster now a lot of the time.
Yeah, so what you do there then is you take in LSPCIe or something, you can figure out which cores are handling the interrupts for those said devices. And on those cores, you can basically, or threads more accurately, you can tell the kernel to not go to C2. And that'll give you the best of both worlds. You'll get better network throughput, you'll get better network latencies, you'll get the most performance that we can offer. Those basically handle 99% of our cases in our experience. So please do not disable C states. A lot of people, I cannot begin to describe, who just turn off C states. Please don't do that. Not on AMD hardware at least. Please don't do it. The next option is kind of related to C state. We can, if you change this option, we basically, this is the weight that the kernel uses to determine how often it should take a core to deeper sleep states. If you change this number to be higher, the kernel will not go into it too often. But if you make it lower, it'll try to be more aggressive, and because it's like, oh, the time is, these values are not typically, the way the kernel interprets this is different. The kernel guys can tell you, but from our perspective, if you make the number smaller, more C state transition. If you make the number bigger, lesser C state transition, right?
So if you're running some kind of workload diagnostics and you see cores going to sleep a little more often than they, maybe you could bump this to 125 and then run your benchmark.
And the funny part is, because of Linux being Linux, you can also just override this in the kernel itself. You don't necessarily need to do it through BIOS, but we allow people to do it through firmware as well in case they need to. Right?
Neat. PPN opt-in. Oh, this is the serial number thing.
Yeah. So if you turn this on, you can read the serial number of the processor from the operating system.
Globally unique.
Yeah. And I think you want to talk about why serial numbers become important in a large fleet.
Yeah. So it's you have to opt into it, right? Because if you're worried about people knowing what your specific hardware is, it's you can leave it off. But let's say you're running a large-scale data center, right? And you want to know in the operating system itself, what part am I running on, right? This is a way, if you opt into that, you can then read the PPN and we can get the serial number information. It's good for machine check logs, it's good for kernel crashes, all that stuff.
The single biggest use case I see is, like, let's say you plugged in an order for 1,000 servers, right? And you've received 1,000 servers, but you have, your servers are off-site and someone else is managing it. It's like a co-location somewhere. You don't know who has physical access to the hardware. This is a great way to know. If you take the serial number of every part in a system and hash it together as a unique ID, now you know if someone changed hardware around without you knowing. Right? Let's say a machine goes down. Right?
So it sounds like a small thing, but just knowing which CPU had the problem is sometimes half the battle.
Half the battle,
nice,
right?
So
just being able to find it. So,
It's like, oh yeah, I remember that processor. It's got this weird problem. Why did that come back from?
All right.
SMEE?
That's secure memory encryption. So we have SEV, SNP, all these memory technologies. SME is a big part of that as well. That's more transparent. So underneath the covers, basically it's there to save you from what it's called cold storage attacks, where someone comes evil made attacks, or something where someone has physical access to your machine. Let's say it's an edge device, you don't have it, but you want to ensure all of the data at rest was always encrypted, that'll do that for you.
Yeah, that's I could imagine like at a cellular tower site or something like that. Somebody breaks in, the machine's running.
Right.
Very quickly, they can pop a DIMM out, put it in a thing, and in a couple of seconds, you can read most of the data from the DIMM.
And all you need to do is get any passphrases or anything. So that's why we support it. Typically, we've done a lot of work in our memory encryption, as you've reviewed in your channel before. The overhead for this is fairly minimal. So
it's been coming down over the generation.
Yeah, if
I
you
think
can
it was like 1.5% for Zen 5, which is almost nothing.
It's very small. It should be very small. And that's also in cases where you're actively benchmarking. In real workloads, it's in the noise. There's so much noise in the workload, you'll barely see it, right?
Fast, short, rep, MOV, SB, FSRM, and enhanced rep, MOV, SB, STOSB.
Yeah, so
I've seen these on Zen 5 desktop.
yes. As we, x86, people say x86, I think of it as one thing, but there's different capabilities you can enable, like AVX, AVX 512. So enhanced rep move is, faster in different ways of doing large copies.
It's on auto. Is that enabled or disabled?
Auto means whatever AMD thinks you should be running, right? So typically, I think that's a good segue to talk about. Typically, when you look at AMD options, you'll see either if it's like an on-off switch, you'll see enable, disable, and auto. Typically, auto means, hey, whatever is AMD recommended. So if you don't know something, keep it to auto. It will be a safe backstop for you that the setting is not.
Yeah, and this used to be a big question always. Right. So we've tried to improve the text string. So up there it says auto equals enabled, right?
Yeah,
okay.
We are trying to get there, but there's so many options, and the help text is not necessarily. And also, this is like a Supermicro system, right? But other systems like our other OEM partners may have a different way to expose BIOS options, so they'll have their own help text. So we try to keep it as generic as we can. So it's a bit challenging. But that's why we have those workload profiles. So our hope is eventually people just see that and change it. And then our versions of that, we work with our OEM partners to also do similar tuning, right? So that makes life easy for everyone.
Now, IOMMU Auto is kind of haunted. If I understand this correctly, and correct me if I'm wrong, IOMMU Auto is a partial enablement which supports legacy operating systems, because sometimes if you're IOMMU, the number of devices in the IOMMU group is more than like 64 or something,
the
operating system crashes. Yeah. And so enabled is fully enabled, auto is partial enablement, and disabled is disabled.
See, the IOMMU setting, as you said rightly, it's not necessarily one of those, I would say, light switch settings. Those are more like, I would say, real hardware biases, right? So some of them like pass through, you'll not see in a BIOS option, but you'll have to have your kernel driver say it. So IOMMU is kind of a dance between the driver and the BIOS, so it's like a unique case. But yeah, with IOMMU, try to keep it enabled, don't disable it. Especially one major use case for keeping IOMMU on is if you buy a large threaded machine, you may not be able to enumerate all of your cores if you don't have IOMMU on.
We'll get to more of
you
that.
Want to talk about
you get in trouble with Saravi, our Linux guy.
Our Linux guys who maintain the driver, they'll scream at us if we...
AVX 512, that makes sense.
Actually, go back, that's a good... All three options, there is another cool reason why we put them in. So let's say you were live migration and having a cluster of systems. Let's say you have Zen 3 and then Zen 4 and now you get Zen 5, but you want to ensure VMs can get migrated between all of them. These three options, you can match the CPU ID option so that even when you buy your new Zen 5 system, let's say you buy it for virtualization, AVX 512 may not be a thing that you care about, but you care about live migration more. If you turn this off, the CPU ID turns it off. So now you can have live migration between Rome, Milan without anything if you want to as another.
Or if you have non-virtualized job queues.
Yeah, if you have non-virtualized job queues. So you can do that as well, right? If you have onboarding a new class of machines, but you want to ensure live migration, you can probably tune some of these out if you want to.
Neat. Monitor M-Wait. Monitor and M-Wait disable.
Yeah, we talked about that. That's another way that the OS can basically halt the system, right? It's a lighter weight thing, it's a higher performance thing, but not all OSs support it. So
some legacy OSs don't like to enter C states using M-Wait, monitor M-Wait. So you disable this, your older OS may work.
Yeah.
We encourage you to look at our support site and please only use things that are validated. But in case you have something.
Ancient install guides for, I think, even Microsoft SQL Server are like, disable all C states in BIOS, but that's from like, Socket 604 Xeon era, so it's kind of like, you need to update your knowledge.
Still in the documentation.
Yeah. It's just like, it's not now, but L1 stream hardware prefetcher, L2 stream hardware prefetcher. This one on Zen 5, I think when I was messing around with these, it would make the benchmarks worse, but game performance would be better.
You want to talk
when
about
you disable them?
Or when I mess with them, the benchmarks got something.
I mean, we can go into it. As the name says, these are stream prefetcher. So stream is a very common memory bandwidth test.
Or a memory pattern, right? You're just
memory
streaming
pattern,
data.
Yeah. So there's different things like triad, whatever,
Right.
right? And so these prefetchers, they help with that stream performance, right? So it helps with just memory bandwidth in general. But like we said, for gaming, sometimes memory bandwidth isn't.
Latency is more important.
Latency is more important. So some of these can be kind of at odds, right?
And-
So,
this game likes latency. This game wants bandwidth.
Yeah, and it's more like sometimes a prefetcher can wash out your cache, right? If it's not doing what a stream sort of access, and so you really want to keep things in your L3 or your X3D cache.
To explain that a little bit better, sometimes when you're doing, say, write to memory operations, you want to bypass the cache. Like you're going to write it and never look at it for a long time.
Yes.
And if you cache those operations, it's going to negatively impact performance because it's evicting everything from the cache.
Yeah, something that maybe you did want to use.
This is another one of those cases where if you use, like software is pretty, everyone thinks hardware is hard and software is hard. Like software changes. In fact, hardware changes more often than software. So customers are typically running 10-year-old games, 10-year-old database applications, 15-year-old use cases, right? And those use cases may not be as smart to realize, oh, I'm storing something to memory that I never intend to read back. So there is a way you can do that in x86 called as streaming stores. So if you did that as an application, like none of these settings would matter, but most applications don't do it. So we have to do it on their behalf, right? Same thing with prefetchers. So if anyone is learning x86, you can do a hint to x86 and say, hey, this is software prefetch. Okay, I'm going to use this again.
Yeah.
One more thing to say about these two settings is if you go look at our public documentation called as the processor programming reference, we let you change this at runtime through a model-specific register, also known as an MSR. So you can change not just these two, but also bias them differently. So you may want to explore that if you want to. But
that sounds like something that could go in some of the gaming control software.
You can do that, but just a word of advice, the modern kernels for security have disabled direct access to MSRs.
Yeah.
So you will have to say, MSR.allow_writes on for you to have
Sounds like
access
another
to.
patch to turbostat.
It's our domain, Wendell, but I'm here right now.
CCD control, core control, and SVM mode.
Oh.
Yeah, so this is ways to what we call soft encore, the part.
Yeah.
So if you go into CCD control, that's core control.
That's core control.
Yeah, so if you go into CCD, so this is an 8 CCD part, right? It's a 64 core. You can say, hey, I want to only enable 6 of the CCDs, 4 or 2. Auto is all 8. I don't know why.
And one major thing about CCD and core control is, actually go to core control first, we'll talk about it.
So then core control is per CCD or CCX, how many cores within that complex are you enabling? And so you can go 1 to 8, right?
Yeah,
and now you're asking, why would you ever turn off cores, right?
Well, you can give more cache to the cores that remain.
Yes.
And there's another use case.
Well, yeah, so one is performance reasons if you know, you want more cache per core. The other is licensing reasons,
Oh, yeah.
right? So sometimes just having more cores enabled, you can incur extra licensing costs.
There was a guy I helped on the forum who literally bought this exact CPU single socket configuration, and he's running 1 core per CCD because licensing and cache.
Yeah,
And
exactly.
that's why we let you do these changes, right? And another major thing that is a little bit different, if you see 1 plus 0, some of your users may be confused. So you can have situations in this setting where if you have a Rome system where we had 2 CCXs per CCD, so you had to keep things symmetric. And we also had Bergamo, which also had 2 CCXs of sorts. So that's why the BIOS option looks weird. Just if you see 1 plus 0, ignore the 0. It's okay. Don't be scared.
Sometimes the 0 is not 0.
Now,
sometimes 0, not 0, like he said on Bergamo.
So as OEM's system, not every menu option will look like that, right? So your mileage may vary, right? So please keep that in mind, right?
And then SVM mode?
That's basically virtualization support.
Yeah.
So if you want secure virtualization,
Yeah, and that should be on always. No one should mess with that.
Sometimes BIOSes call it AMD V. That was the original marketing term for it, but that's more like the industry standard term for it.
And then we have Northbridge, the IOMMU, DMA-R, DMA protection.
Wendell, I think you know these settings better than us.
I've
You should be teaching us about these.
You tell us what your feedback is. I think you know and your users know more about these settings because of GPU pass-through than us at this point. But
so DMA protection, sometimes that's boot only and sometimes that's boot plus operating system. And so this is direct memory access. This is like a hardware mechanism to enforce direct memory.
DMA protection also is a big client thing because of Thunderbolt and USB 4 cases where you can have PCIe.
Yeah. So the
semantics
danger zone there is I make an evil maid type device device and I
Yes.
plug it into a Thunderbolt or a USB 4 port, I can dump the contents of memory from the system completely. Like that's a feature, not a bug.
As I said, these settings are maybe more like between us three, or you may know more than us.
DRTM virtual device support. I have no idea
This is
what
dynamic
those
root
are.
of trust measurement, right? It's basically
I had no
related to yeah, right. This feature has been there since Bulldozer, right? Basically, it's related to how we boot and set up the root of trust. If you don't know about these settings, keep them on auto, but these allow you to change because Microsoft has a bunch of specific features with Secure Core PC that need to be turned on in case for even Windows Server. So
For ACS enabled, so this seems to need to be enabled on modern systems for IOMMU and everything.
and the groups to be enumerated correctly, right?
Yeah, so this is again related
It's
to
a very harmless
hardware.
setting. Please keep this enabled. It should be enabled by default. So if you see something different, call it out.
I'm going to skip over the TDP
No,
stuff.
actually, let's stay there for a while.
Well, no, because
oh, sure. You want to keep it to the IO stuff?
yeah, there was one more. Is it APB DIS? Is that the
No,
other
that's
one?
also power related.
I thought there was another.
No, you may want to talk CXL first if you want to, and then we can go back.
We do have, okay. We'll skip to CXL memory support. So enabled, disabled, and auto. This is another one where auto means something different than enabled.
Yeah, it may typically, ideally, you want to keep the CXL memory attribute enabled because that will enable you. The way CXL memory expansion use cases work is you want to have your CXL device told to the OS as what we call as a headless NUMA domain. Where
Yep.
it's
And I
got,
did a video on that. You should check that out.
So-
We talked about it for like an hour.
Yeah, there's a lot of work being done that ensures Linux's memory allocator has a tiering logic. We don't break it. So it knows that this memory is further away.
Yep.
Plus also this memory doesn't really have any affinity to any of the compute. So
Yep.
the only real semantic to describe it is like, hey, this is a memory domain, so it's a NUMA node because memory, but it doesn't have any compute.
So just a quick summary if you didn't see that video. This is a smart modular PCIe Gen 5 CXL device. It's DDR5 on what looks like a PCIe card. It uses a PCIe interface. It's technically a CXL, not PCIe, and it shows up to the operating system as a NUMA node. A NUMA node is normally associated with like a processor, like another processor socket, except there's no processor resources in this NUMA domain. It is just memory.
Yeah, and the big thing is it's coherent with
It's
the rest
coherent.
of the
And
memory and
it's
stuff.
it's a great use case for people adding more memory capacity. There's a lot of use cases where people just want capacity, not as much performance. And with tiering logic becoming better, we are hoping that folks can have a big advantage there.
You can also the platform supports lying to the operating system if the operating system is terrible and old, but there are latency penalties with that. We talk about that in the other video.
As we said, you know more about some of these than us.
All right, so now we have power, TDP control, package power limit, and determinism.
Let's talk about TDP and power in general a little bit. So those two options, a lot of users, even the smart ones, I would say, confuse TDP and power, right? And I'm just going to say that out loud, right? There's a number of times people are like, my TDP is 200 watts, I can only draw 200 watts of power. Not true. TDP is thermal design power. It's purely a statement of you telling the processor what is the capacity of cooling for your thermal solution and your environment. So in data centers, your thermal solution is not just the heat sink, but also the ambient air temperature and pressure and humidity, right? So all of those go into the equation. So all you're doing with the TDP value there is you're telling the controller inside our processor what kind of cooling capability your thermal solution has for us, right? So we can do certain things, and we'll get into that. The power limit is what we call the real power limit for the chip. So when you set that to like whatever lesser value, we'll track the real power of the chip, or we'll try to the real power in the socket to limit it to that value on average, right? That's our goal with the power limit. That's why it's called package power limit. It's the power for the package that we deliver to you. The typical configuration we ship it at is TDP equals PPT. So package power limit or package power tracking and TDP, thermal design power, are kept to the same value, right? Now, with that out of the way, determinism comes into the picture, right? And I'll start, maybe Amit, you can add more given your experience, but determinism, if you go into that BIOS option for a second, I think it's better to first enumerate what that setting does. Yeah, first set it to manual, right? And then there are two options, right?
Power and performance.
Yeah, so I'll ask you a question, Wendell. If I set it to performance, do you expect more performance or less performance?
I expect less performance.
Because you know. But the typical user goes and sets this to performance and then calls us saying, my performance is worse.
Yes.
What do I do? And the real reason for that is when
It's deterministic.
it's deterministic performance.
Across a whole population.
Across a whole population. That's really what the performance of the part across a whole population is deterministic. And when you change the option to be power, the power across the whole population, given the same workload, will be deterministic.
But the performance can
will vary.
Now,
Exactly.
AMD guarantees that you're going to get a minimum amount of performance, but you typically will get a few extra percentage points of performance on average.
So that's why all of our perf claims for parts that customers can buy will be made mostly on performance determinism. Some parts like the 9575F are different. They are based on power. Because you're trying to, it's like the sports car of things, right? You want the best, right?
It's 64 5 gigahertz CPU cores, server cores, which is just absurd.
And all our cores are created equal, as you know. Do you want to talk about variation, where it comes from? Maybe you can answer.
Yeah. So the way we manage things in the part, we have what we call per part fusing, right? Where we characterize the part in manufacturing and we say, okay, here's how leaky it is. Here's its frequency voltage curve. That determines, basically how much power it takes at a given operating point. And so to be deterministic, you basically have to use the same fuse settings for every part, right? And you kind of try and find something that floats all boats, right?
Or one of the parts that we can be like, this is maybe the worst case part that we can build, something like that.
Yeah, 3 sigma, 4 sigma.
4 sigma, exactly.
Yeah, wherever it is, right?
Like a distribution.
And so instead of using the real fuses for the part, we use the kind of common fuses, right, to determine the performance of the part. Now, when we actually set the frequency and voltage, we use the real per part characteristic. So we're not overvolting the part for no reason. But as far as the performance you get, it ends up being the same across all the parts.
Across all the fleets.
Yeah.
And also, this is the key point of determinism. If you set your determinism to performance, you have to ensure as the user that the TDP value and the PPT value are the same. And you cannot go below the part's minimum TDP. So the TDP, like PPT can be varied to a larger range.
Yeah, there's guardrails for...
Yeah, but TDP can only go between, let's say, 320 to 400. So if you want deterministic performance, rule number 1 is you have to have TDP equals PPT. B, you cannot actually lower either of those values below the minimum TDP of the part, because then that breaks the distribution characteristics Amit talked about. Let's say the part is like a 400 watt class part, right? So 320 to 400 watt class part. But you go say, I want performance determinism, and then you go change it down, right? To like 250 watts, you're not going to get deterministic.
Yeah, it's no longer guaranteed.
It's no longer guaranteed, right?
Yeah, which is fine.
But we highly encourage for most users, the place where I'll talk a little bit about who should be thinking of using determinism as performance and power. First order of things. If you don't know what this is, or you don't understand part-to-part variation, you're probably okay with power determinism, because you don't care about it right now. If you've never asked this distribution question in your workload, that means you don't care about it. That's the rule of thumb, right? Second is, unless you are someone who's operating like a really large fleet, where you've made minimum performance guarantees of some part to your user or to your application space, you probably do not want to set it to performance determinism. Now, a lot of our parts, because of the performance claims, are set to performance by default. And if you don't care about it, we highly encourage you go change this if you want to. If you want more performance, more real performance.
Now, sometimes I've noticed the default CTDP is 50 or 20 watts less than the maximum CDP. So it's like we got a home labber and they picked up an amazing part on eBay. You could actually go set this to another 20 or 50 watts, and as long as your cooling solution, I got a Silverstone AIO 360 in there, can handle it, then you just get more performance for free.
And we kind of did this on client as well, right? If you were to set it to the max, then if you went over, that would be considered overclocking, right? But by giving that headroom in there, you can, if you have the additional cooling, you can get it and still be under warranty, under spec.
And do want to say something, there are some systems, it's actually bizarre. Servers are, in some cases, more power limited than even some laptops in cases, right? Like, it's a bizarre statement I know I'm making, but there are people who are trying to fit into an edge form factor or a really dense, twin-like form factor or some other very power dense form factor.
A lot of data centers out there are very power limited.
So what the system designer may have actually only put 320 watts worth of, power component in there or validation in there for their thermal solution, right? So sometimes the system may actually put a hard limit at 320 underneath the covers in their firmware. So you can go change the setting to 400 you want. The system won't go above that, right? So we allow our system builders to do that so that you have a stable experience. It's a server. Step one is, it always has to be up. It cannot go down.
And then we've also got power profile selection, like balanced, maximum, high performance mode.
So this is, in case you don't know, the workload profile that you selected was about the overall system configuration, like things like SRIOV, things like resizable bar, things like it encompasses everything, including the power. But
you get a power budget for the I/O die as well as cores.
So this is a setting in case you have a custom configuration and you want a specific profile selection just for the power management of the chip, you can do that.
And there are white papers that explain this in detail with specific, like you're going to run PostgreSQL in this configuration of blah, 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 set this.
Yeah,
So
we are trying to get you information if you don't know. Hey, let's talk about APB dis a little bit. That's an important setting.
Okay.
So you remember the setting that you exposed, core performance disable?
Yeah.
So this comes from a little bit legacy. Our original chips, which were like the Optron 6000 class, used to have this feature for boost core performance boost, right? And that's why the setting was core performance boost disable or CPB dis. So when we started with, I would say ROM class processors, that's really the first time we had to do this. The I/O die also could regulate its power a little bit. So we were like, hey, what do we call it? So it was called algorithm performance boost. And then the setting to disable it of sorts or to control it was called APB dis, similar in CPB dis. So typically what will happen is your chip may regulate its I/O performance depending on what the chip thinks where you need performance to. Like if you need more bandwidth, it'll give more power to the I/O die than the cores. And if we think you need cores, we will actually throttle the I/O die to give the cores more performance, right?
So the BIOS designer only gives us the option of 0 and 1. They weren't even confident enough to put in on or off.
No, there's a couple of versions of this.
Because there's dis in the name too. So
there's a couple of ways to do this, right? Typically what you'll see is once you say APB dis equals 1, right? There'll be another option that shows up right there, DFP state. So what you're saying when you say APB dis equal 1 means you've enabled APB dis. I am so sorry, we're trying to make this better. But you've disabled the ability for us to auto-magically change your DFP state. So you have to tell us what state you want to be in. And typically any processor has 3, like you see it says on the help text 0 to 4. Typically 0 is the highest state, just like cores, right? C0 is the highest, so we try to follow some convention. So if you say 0, that'll give you the maximum PCIe, I/O, and memory performance out of the chip. If you say 1, it's somewhere in the middle. If you say 2 or 3, it's like the minimum that you can find. Yeah, it's giving the cores, right? We highly encourage you to keep this setting off, right?
It should be on auto.
It should be on auto. Keep things on auto as we recommended. But if you remember we talked about the HPC workload profile or the high performance selection. The HPC users want this to be not happening to them. Because there's another part, every time we change the state, there may be a time where there is a little bit of what I would say is jitter, essentially, where the chip doesn't, because it's changing memory states, you can't access memory, right? Right. So it has to block access.
And some hysteresis, right? Where you're in the slower memory state when you are streaming a bunch of memory, so you lose some perf as you're switching.
Yeah, as you switch, you lose the perf, and then you can get into some cases. The reason why the BIOS option exists is there are some customers who have very unique cases where they get stuck in the middle of the hysteresis. So their workload is just enough core and just enough I/O. So sometimes they're like, oh, we need cores, so DFP stayed low. So that's the reason that option exists.
And some of that can be controlled with a more modern kernel, or you could do it in software.
So this is where we want to talk. The package power limit, the APB dis, and the C-state stuff. We have a thing there's a kernel driver called as HSMP, which stands for Host System Management Port. I have the dubious honor of being the guy who had to name that thing. I am so sorry for the name. We couldn't come up with something better. Happy to take suggestions. We also have a library called as ESMI, which is a helper library that works. It's like a user space library that works with the kernel mode driver. The driver is mainline, so you can look at the code. We have documentation in our public processor programming reference PPR document, the public PPR. You can see what the different messages are. You can change things. In fact, you have even more control now with Zen 4 and Zen 5. It can tell you why your workload is giving you lesser performance. Like, hey, what is limiting your frequency? It'll tell you, oh, it's current or it's thermal or it's power. It'll tell you what is happening.
Handy.
It's
I
really
need more
handy.
details on that.
Yes.
Video too.
Yeah.
Oh, you can do a whole video on HSMP. Yeah.
Like a ton of our data center class customers use HSMP as a management layer in the control fabric because imagine you're a cloud service provider. And you have like 15,000 workloads you have to onboard. Not all of them are going to be the same. So we put a lot of like the shadow MSR that we talked about, the prefetcher logic, HSMP settings, the SMT settings that the kernel can do, the idle states. So we are trying to get as many of these tunables, runtime tunables. So we don't want someone to try to run a game and say, hey, I need to reboot my system to run a game. Right?
Yeah, it's kind of like on the car, the access port, right? You can talk directly and see what's going on.
HSMP is more like your car access port. People put that debug header, right?
Yeah.
So it's kind of like that.
And then we've got DFC states.
Do you want to talk about DFC states, Amit?
Yeah, so DFC states are similar to core C states, that when the part goes idle, we start shutting things down, slow down clocks, turn them off, right? And so again, you can enable or disable this feature.
What's DF stand for?
Data fabric. Sorry. So data is data fabric. So
it's the infinity fabric.
Yeah, infinity fabric's the external term, but basically it's what we connect the cores with.
Nice.
And DFC states is
memory
like
and I/O.
a good mental model to have that has helped some customers is it's like a hierarchical C state. So first all the cores have to go idle on a socket and then the fabric can go idle, right? So it's really a deep idle kind of a case where let's say your system and servers are not being used in the night, there's very little traffic, high chances that your top shows 0% or task manager shows 0%. So chances are we've entered DFC states and shut down everything, right?
What about data link feature cap? And when I enable that, I get more options.
You'll see, just let's go through it, right? So these are like settings that really I recommend no one changes, right? That's it. You can't change. I just want to show that, how do I say this without being, you shouldn't care about these settings.
Okay, fair enough,
Okay,
that's fine.
yeah, pass.
Yeah, that should be a pass, I would say.
SEV SNMP support.
Yeah, that is secure encrypted virtualization, right? And secure nested paging support. That's related to our security features we have for multi-tenancy and a bunch of stuff.
The operating system can delegate to the hardware memory controller
Exactly.
a lot of management of that kind of stuff. And that's very well supported in the Linux kernel.
Yeah, now the kernel supports it. We have a bunch of cloud service partners who have virtualization.
VMware just got support.
Yeah.
Yeah, when you hear about like something like confidential compute or something like that,
This is confidential compute.
Yeah.
So we are pretty
Periodic
happy
training
about
mode legacy. We were talking about this earlier.
Don't. Let's not go there. Let's just keep this one.
That has to do with DDR5 training and the margins that you have, and you should leave it alone with the defaults that your BIOS runs on because it depends a little bit on the hardware implementation of the board.
Yeah.
EQ bypass to highest rate.
Again, this is
Related
something
to
you
that,
should, just leave it to auto.
We covered CXL, sync header bypass.
Yeah, that again, something that you shouldn't touch.
Sounds good. Okay, memory configuration.
Yes, this is a cool one.
Target speed, this board will let us go to 6,000 and 6,400, which, this is epic. Some people say this is overclocking. It kind of is and kind of isn't.
Because
it's not technically overclocking because the DIMM has to support it, right?
Yeah.
So
the logic is we will never let you override the SPD.
Right.
Right. That's the first one. The second one is the board manufacturer also has a way to block it to 4800. So you may select this option at 6400 if it's exposed, but it won't really do 4800. And then there's also support, right? Genoa only supports 4800. So if you put Genoa in there, you'll only get that.
Now I think at the press event it said that vendors could qualify their own married package.
But again, their system firmware controls that. We as AMD, our official support is.
You're going to buy a board and CPU. And,
Yeah, this might be more for the platform.
Folks, right?
Memory interleaving, we definitely want to do that. All the memory channels interleave.
Do not disable this, please. There is no case that should be disabled.
Chip select interleaving is auto and disabled. Now sometimes I see some options in here about
rank interleaving, and bank interleaving. So if you look at DDR, like dual rank memory, you can also interleave not just the channels themselves, but the rank amongst themselves. That gives you another 5 to 10% performance.
Bank swap mode and CPU option.
You should not really care about this.
I think it gets into how we hash
the addresses, right?
And power down enable.
Yeah, power down enable is a cool one to talk about. So when you go idle, like in self-refresh kind of cases, we can power down the memory controller. So if you care about latency, you want to disable that. But overall, you should keep it auto. It's really
but like for gaming, for things like gaming, you probably want to disable that because it will affect your latency.
DRAM scrub time. Let me see if I get the definition of this one right. The hardware, when the memory is idle, will walk the memory to see if any bit rot has occurred, if there's any errors. And if there are errors, it will correct them.
Very close to it, right? It's related to what you're describing is the patrol scrubber, right? That's its job. What it'll do is if it finds something wrong, it'll basically mark it bad until the OS writes to it. And if someone writes to it, it'll basically generate what's known as a deferred error. Like, hey, you can do something, it'll let the system know now. There are multiple ways it'll let the system know or the BMC know, depending how the system vendor has set up the board. But yeah, that's what that scrub time.
There can also be a leaky bucket aspect of this as well, where it's just like, there's only one error. I'll just sort of not.
Those mostly apply to like correctable errors, machine checks. And again, depending on your system vendor, some system vendors want their BMC to handle the machine check. Some people want the OS to handle the machine check. So we support
Sometimes
both.
there's an option here that's like error handling OS first or platform first.
Exactly what I was referring to.
Yes.
Yeah. TSME.
Wendell, you can get a job at AMD if you're interested. FYI, just letting you know.
An enhanced PPR, which is disabled by default.
PPR is post-package repair. It's a way that we can work with the memory to get.
We talked about that in the DDR5 video.
So please refer to that video. It's basically that setting.
Yeah.
Right?
Post-package repair is this amazing, crazy. So we were on a path. I'll take 30 seconds segue here. We were on a path to ruination and a lot of explosions and terribleness with DDR4 in the data center, and that was because everybody was adding 1 or 2 terabytes of DDR4 to their servers. The rate of errors wasn't decreasing. All of a sudden, DDR4, like it was like catastrophic, like teeth gnashing, people losing their minds. DDR5, like flash memory, has spare cells, and you can like literally post-package repair in the system. It can be like, oh, this row of memory has gone bad. Cool, we'll just use this other spare row of memory, and like post-package repair is the thing. Check out the video, it's just completely nuts, but that's what we have to have in this era of, oh yeah, this thing totally has 4 terabytes of memory.
There's also another cool feature in the Linux kernel and even Windows where you can do page retirements, right? If in runtime you can't reboot or something like that, right? You can do things that way as well.
Let's not trust that region of memory. There's this ancient patch for Linux called badmem, and it's like that. It's like a hardware feature now.
Yeah, and we talked about RAS in one of the videos, reliability, availability, and serviceability. What's interesting is 30 years ago, you had 1 core in a system.
Right.
It had the same requirements as a socket now with 64 cores.
Not 64,
or
192,
yes.
Right? Or 128.
Now, the only other things that are really relevant are a couple things under PCIe PNP, resizable bar, which I think everybody is pretty familiar with.
Oh, we have that ACPI option, right? The NPS settings and whatnot, we should go through those.
Oh yeah, under memory.
Let's go. I think it's an ACPI in the North Bridge setting. ACPI settings, yeah.
Okay, high precision event timer. This is like a hardware timer so that the operating system is not counting cycles. So that's handy.
Yeah, it's called HPAT. It's kind of a legacy way of counting time, but
typically things will use in a timestamp counter TSE. The HPAT is there in case you want a slower domain clock.
Yeah.
PCIe AER support, which I'm going to disable.
You want to talk about it?
So this is a great. We run into problems all the time with PCIe AER when I'm using all my little weird adapters and like. I've got stuff like my E1 SSD.
The ruler.
You know, these will generate errors if they have bad adapters, and you need to know, like that's a good thing. But you can also have certain classes of storage device, like Samsung NVMe didn't really handle sleep and wake correctly on PCIe link states, and so it sprays the system with errors, but the errors are benign. And so it's annoying to get the errors on the console, but the errors are basically okay. Samsung had a firmware update to fix that because we, as an industry, we agreed on how those errors should be handled. Generally, you do want PCIe AER on, but certain older GPUs throw those errors and certain storage devices throw those errors, and there's nothing you can do about it.
So if you don't want dmessage or syslog to be spammed,
yeah.
In those cases, you do that, right? But we typically
and you understand the errors, yes.
And you know, like you sign it off. It's like, you know, those waivers that you sign at the hospital. Like if you disable AER, remember you're signing one of those waivers, right? Like
NPS is pretty well documented on our forum. We love NPS 0 for machine learning, even though it's like terrible. NPS 0 is like another unholy hack from AMD, and it is glorious.
First of all, the official statement is NPS 0 is something that we really do not want you to use. Like it's not a support.
It's in the BIOS.
No, it's one of those gray areas, right? Like it's been there since Naples, right? And the official stance, if you go ask, if you report an issue to us saying NPS 0 is broken, we'll be like, yes.
Yes.
Like,
sorry about your luck.
So your mileage may vary. Just like if you look at those options, NPS 0 should be looked at as like your mileage may vary option. And if you care about NPS 0, you should really look at your application stack.
Yeah.
Like someone should be looking at the software before they ask the hardware to change.
On this platform, NPS 0 doesn't matter because it's only a single socket. Right. So on a 2-socket platform, it makes the 2 sockets appear like as if they are a single socket.
It's like one socket to rule them all, right?
Yeah.
So
a core on one socket, you could say, oh, memory over there is just as good as a memory over here.
Anyways, but NPS 1, let's go into that, right? NPS 1, NPS 2, and NPS 4. NPS 1 is our default, right? NPS 1 basically ensures when you have 8, 12 channels of memory, all of those channels are basically put into a pool together for software to see, and then that's what they can allocate memory to.
That has a very slight latency penalty.
Yeah, it has a slight latency penalty because you're crossing multiple regions inside the socket, right? But it's very tiny. We highly recommend just keeping NPS 1. Do not change it until you know what you're doing, or if one of the workload selection options has done it for you. NPS 2 is basically the best of both worlds. NPS 2 basically ensures you split the socket in 2 halves, right? Right down the middle. So one half has 6 channels, the other half has another 6 channels. So if you have a 2-socket system, you'll have four halves of the chip basically, or 4 NUMA nodes. Also applies to I/O. You have to remember, I/O is not cheap in terms of bandwidth, right? It needs a lot of bandwidth for PCIe Gen 5 bidirectional traffic, and if you put 2 of those devices. So NPS 4, as we go into NPS 4, remember that a bunch of our OPNs will support NPS 1 and NPS 2. Some OPNs may not support NPS 4 because of the way the CCDs are. We can't
and the PCIe lanes.
And the PCIe lanes and everything. So just ensure NPS 4 is a more, like, you can easily do it on, typically 32, 64, 128 core parts. NPS 4 is something you should only use if you really, really know what you're doing, because you can potentially get into I/O hotspots where you have a bandwidth hotspot, right?
There's a couple of physical system configurations that I'm aware of that use NPS 2 by default because they're tuned to be very consistent in the I/O. And we're talking about a jitter of like a couple of nanoseconds. And so the I/O cards in those, they're all 16 lanes, but they're split so that 8 lanes go to one socket and 8 lanes go to the other.
Exactly.
To
it's like a quality of service thing for them that they use it. So we want to give you guys those options, right? So we do try to expose these, but typically NPS 4 is something you should know if you really know what you're doing. And NPS 1 is pretty good.
And then if you really want a lot of NUMA nodes, you can turn this option on.
It's for the NUMA node lovers. So I have the dubious honor, along with another person at AMD, it's Krishna Bernuccio. The two of us hacked up this BIOS option during Naples, and I'm going to call it a hack.
Carefully architected and
but at the time of Naples, we had this situation. It became more architected with Rome, I would actually admit to it. Because with Rome, we also handled the IO NUMA case. With Naples, it was purely like a pure scheduler concern, because during Naples, a ton of operating systems and schedulers and even some job schedulers had incorrectly made the assumption that a NUMA domain has a singular L3 domain. And that was not true in Naples, right? Because you had CCXs and then you had multiple CCXs. So how do you tell like an older scheduler that this is not true? Well, they can patch like we did with Linux or with Windows or with VMware, but when you have a really old version of these operating systems you want to use, or a job scheduler, how do you do it? Well, then you basically tell the job scheduler each CCX is a NUMA domain. So,
or you can run the old software in a virtual machine where you lie about the topology. Yes. There's a thread for that on the forum.
You guys are experts at that, but we had to do something for just the standard customers.
It's like the original Project Lasso.
This is Project Lasso before Project Lasso, right? If for the users who want to use it. So this also an interesting story about this option. We didn't realize with Rome, because Rome had 8 CCDs, each CCD was 2 CCXs, and you could have 2 sockets. So when you turn the setting on and you say NUMA control, or you go to Windows, you'll see 32 NUMA domains, and like you have to start scrolling NUMA control output, right, on like a terminal.
That sounds like an OS researcher.
So the OS research community started reaching out to us, and they're like, hey, can we get this server? Can we benchmark it? We're like, why? They're like, oh, we are trying to do job scheduling. How efficient can we make the scheduler? And we want to try to do rack scale computing in the future. And they're like, can we just test it? I'm like, go right ahead and test it.
Yeah, it's a great little
it mimics a rack or something.
Imagine a rack with 32 servers. But if you wanted to run like an SMP OS, if some researcher wanted to do it, this is the easiest
model way. It on the thing.
This was a model for it. And there were so many software bugs found to do this. So in 2025, you should not need that BIOS option. Okay, I'm just making that very, very clear. Do not touch it.
And then I'm really excited about the PCIe option. So resize bar, SRIOV, our audience should know that. BME, DMA mitigation support. So this is like boot time. Like if you have a device plugged in, PCIe, or it's going to read memory. So like secure boot, if you have a rogue PCIe device, you could read all your secure boot keys or maybe access the TPM.
Yeah, not secure boot keys are different. Major thing is it's almost like DMA protection just for boot time devices. You want it to be on from the start, right? And then ASPM support is more like PCIe power management support.
Which can also lead to errors sometimes. So that can also be disabled.
There's also a kernel option, no ASPM, so you can use that. I highly recommend using that if you're in Linux, and in Windows also there's a way to do it through a registry. So
PCIe ARI support and ARI enumeration and 10-bit tags, which you get when you enable this.
Yeah. you should keep those on. And you need 10-bit tags for especially PCIe Gen 4 onward devices, especially network and storage devices, right, where performance is very critical.
Some boards still disable this by default, but if you're doing
it's more
any
of a compatibility statement. Like if the board is trying to support really old drives or really old network cards, those cards don't do well with the setting. But typically what the BIOS folks will do, I think it's enabled it after looking at your I/O configuration because you have a device, right? What it'll do is it'll see what the I/O configuration, if it needs the compatibility, it'll go one way or the other.
Let's see, relaxed ordering. This has to do with CXL and memory coherence?
No, this is just PCIe relaxed ordering.
Oh, okay.
Typically, originally the PCIe spec says if you're writing to host memory, right, you want to ensure like the order in which you sent all the PCIe packets is the order at which you want it to be written or presented to memory. Now, of course, after a while, that's not possible when you have all of these different virtual functions, all of the different performance streams going on in a single device. So you want relaxed ordering. By default, it should be turned on, but it's also controlled per I/O device per port. So your mileage may vary because the driver may come in and say, I don't want to do relaxed ordering. Right?
Oh, I can enable it here, but in kernel options, I can say this device doesn't do well with that. I'll disable it.
No, it's not even that. It's the driver that needs to manage it. It's not even something that the kernel really manages. The kernel is completely unaware of this. This is only the PCIe device drivers that know what is happening.
Clock spread spectrum.
I think
there's the intro clip. It's like, that setting's illegal.
Yeah, I would like to avoid any imperial entanglements on this one, so you can read about it on the internet. But effectively, there's regulations around.
And this is because of the clock frequencies in here are so accurate that they can throw off radio frequency interference, which would violate the FCC rules.
There's resonance frequency, right? Like it's like
and especially if you have a bunch of systems, all
in a
at
rack.
the same frequency.
In a rack.
So
it's like if folks don't know, imagine like a bunch that like soldiers who march on a bridge are told to break, break step, right? It's the same thing for hardware.
No Snoop.
You shouldn't care about this setting. I would.
PCIe.
Yeah, I wouldn't put this. VGA priority is actually a cool setting for this board because when you have
onboard VGA or external.
Yes.
Yeah.
So
which can change the way that the bar space is allocated.
Yes, A, that, and B, also you can have a situation where you plug in like a compute device and the firmware doesn't realize it's a compute device, thinks it's a GPU, starts sending output there, and it's chaos, right? So
the connector list, this is just,
So it can be very useful to have from time to time. But this is more like a system BIOS setting than an AMD setting.
Then we have option ROMs, which is just whether or not a ROM on the card can say...
It's like CSM without CSM, right? If you want to load legacy BIOS things.
And then the LAN option ROM. So this will enable things like booting from network.
Correct.
There's usually a couple of settings involved for that. And then there was one other area that was interesting. Was it under CPU?
Yes.
Yeah, CPU information.
These guys, let's talk about this a little bit.
So right there's your bifurcation options for all of your slots.
All the lanes that we support, right, in the single socket. So we have 4 P-links and 4 G-links. So for the users who don't know what P-links and G-links are, in EPYC, the G-links are really meant for like XGMI or for Infinity Fabric that connects the 2 sockets together. So when you're in one socket, these G-links magically become PCIe. When in 2 socket, these G-links are the ones that are connected from both sockets to realize the cross-socket communication, right? So that's why they're called G-links, they're special. And then there's P-links as well. P-links mostly are PCIe links, right? That's
sometimes SATA, but that's going away because no one cares about SATA.
It depends, right? It's still the idea was mostly like I/O links, right? They're never going to be used for this. But then EPYC, because we had a bunch of different system configurations, we allowed different topologies. So you may see systems with 2P2G where you use 2 P-links to connect the socket along with 2 G-links, or you use 4 G-links to connect the sockets, or you can use 3 G-links to connect the sockets that you get more PCIe I/O. The good thing with us is we support full bifurcation on all of these links. Typically, all the CXL support will be offered on P-links. That's why Wendell has to ensure like the PCIe cards that support CXL are in the right slots. Right? If you put it on G-link, we'll really not support it.
Now, in some of the press stuff, I've seen support to X1 and X2.
Yeah, it can. It depends on the system vendor, but there's a limit on the total number of controllers each socket has. So as long as you don't violate that, you can bifurcate it to your HUD's content.
Nice.
But typically, avoid to go below by 2 unless you have like a really slow LOM device. You'll see by 1 bifurcation happen by default for an onboard LOM, which is a gigabit. right? That's where even there, that's gone away from Epic because we've introduced the concept of bonus links. So if you go look at our platform, you'll see bonus links being used for
like,
long.
it's 128 lanes. No, it's not actually true. There's actually another 8.
You want to do AI compute, you want to do 8 MI300X together, we can do all of it now.
Nice.
Right? So it's pretty awesome.
So another thing I was telling Wendell is when we bring up a new chip, one of the big first milestones is being able to boot into the BIOS.
Correct.
And so we're always looking for like a proof of life. And so when we get into BIOS, this is the first screen we go to. We take the screen capture, or actually we take a picture and send it out, to the team.
Also, just so that before the firmware teams at AMD, specifically shout out to Leslie Nicholas, she's amazing, and those guys come and scream at us. It's not BIOS, it's UEFI firmware. Right? But since the user base calls it BIOS, we kind of refer to it as BIOS in this video's context, but technically we should all change it to UEFI firmware, right? That's really what it is.
Yeah, but here you can see it's got the basic information on the processor, so you can prove that you actually booted on, your new Zen whatever, right? So it's pretty
and
cool.
2-socket systems, you'll see 2 of these menus in the AMI-based BIOSes. Then there's the OEM BIOSes, which also will have system information. It's all there, right? We basically allow people to show off this.
Were there any other settings that we didn't touch on?
There's one thing that you may want to just typically look at is typically a good thing to see in here for people to look out for is the microcode patch level. So that's the microcode patch that is being offered by the BIOS to the CPU. And then when you go into Linux or Windows, they may patch it to a newer level as well. So if you are seeing some issues and you want to track what is happening, this is a good way to know what was booted and then what was the OS coming and doing, right? You can also see it in the OS logs, but for a
Yeah, there's some changes coming in the kernel. The kernel is now going to warn you with updates that, hey, you are missing a package that would give you the updated microcode or the updated package firmware or the updated whatever.
The firmware package, right? So, yeah. I think this is just another way for us to express it, right? And yeah.
Cool. Well, that's been enlightening and a lot of fun and the definitive source of okay, now I feel a lot better. There's stuff I learned so much, so thank you.
Don't just randomly change BIOS options. Firmware options. Just we consult level 1 techs if you can't. And we'll be the level 2 techs in case we need an Amit as level 3 tech. Okay, so we have level 1, 2, 3 right here. So.
Thank you guys for joining me. I
really
appreciate it.
Yeah, thanks for letting us walk through it. Yeah.
Check it out and let us know what questions you have for your Epic server BIOS in the forums. I'm signing out, and you can find us there, lurking, probably.